cool way that we can use the calculator to assist us on this problem. So line R, the equation of this line would be y equals, the y-intercept is 3, the slope is down 3 over 3, so negative 3 over 3, x plus 3, and the slope of that blue line, the slope of our blue line here was, well, it had y equals a slope of negative 2/3, like the problem said, plus a y-intercept of 0. So what we can do is we can take those two equations, plot them on our calculator, and run the intercept function. So let me copy those down here. Y equals negative 2/3 x plus 3 and negative 2/3 x plus 0. So check this out. Little technology action coming at you. So we'll take those two equations that we found and we can put them in here. So negative 3 over 3 would be negative 1. So negative 1x plus 3. Remember that was line R. And let's put in line S now. Negative 2/3 x. Negative 2/3 x plus 0. Oops. Plus 0. Let's graph it. Okay. There's line R and line S. Boom! Intersection right there. Second. Trace. Down, 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 down. Number 5, intersect. First curve, hit enter. Second curve, hit enter. Guess, hit enter. There's our intersection. X is 9. Y is negative 6. Okay. So 9 comma negative 6. Let's go down to number 49. Okay, here's what we need to keep in mind here. We're going to be measuring rates of change. So, and I'm going to point out things as we go along here. So we need to tell whether each function is linear. So linear is constant rate of change. Constant rate. A quadratic, the second difference is constant, and I'll show you what that means. Second difference is constant. And the exponential means that the difference in the rate of change is a product. So you can think of the differences, or there's a multiplier. Between the differences, there's a constant multiplier, we can say. Let's do that. Constant multiplier. Alright, so let's see what this means. So from 0 to 1, that's a change of 1. From 1 to 2, change of 1, etc. So what do? Increase of 1. So to get from 2 to 3, that's a change of 1. From 3 to 6, change of 3. 6 to 11, change of 5. 11 to 18, change of 7. Okay, so this right here, what we just did, that's called the first difference. And as we can see, the first difference is not constant. So we know it's not linear, because in a linear function, the first difference is constant. Let's check out the second difference, though. Second difference is 2, 2, and 2. When the second difference is constant, it's a quadratic. Quadratic. Okay, so that first one's quadratic. Let's take a look at the second one. Change of 1, change of 1, change of 1, change of 1. This is change of 1, change of 1, change of 1, change of 1. The first difference is constant, so this is linear. Linear. Oof, man, my handwriting degrading, seriously. Yep, first difference was constant, therefore it's linear. Constant rate of change. And over here you saw that the second difference was constant. That's why it was quadratic. I'll put Q for quadratic, L for linear. All right, let's see what we mean when I say a constant multiplier here. Okay, well, from 1 to 2 is 1. From 2 to 4 is 2. From 4 to 8 is 4. From 8 to 16 is 8. What did we multiply by each time? We didn't add, we multiplied times 2. Times 2. Times 2. A constant multiplier. There's a multiplier, therefore it's exponential. Not pone, ponential. Exponential. exponential. That's funny. All right. Oh, man. We can take that off there. No more Back to the Future. Well, guys, all I can kind of tell you is what I've been telling you this whole year, and that is to do well on any math test, and that is to practice, practice, practice. I will be in my room in the mornings and in the afternoon this whole week leading up to finals. Come and find me. I want to work problems with you. I want you to be successful at math. I want you to be good at math. You don't have to like math. I never asked you to like math. I ask you to work hard. I ask you to persevere. There's, 8 more days of school left? 4 more days of review left. Now is not the time to get lazy. I despise laziness. I loathe laziness. Come in and work hard. Leave this year on a high note. I encourage you guys to come and see me, to work these reviews, to work problems. Visit the other videos I made from units 1 through 11. I made reviews for every single test that we did this year, with the exception of the most previous. And come and find me. Come and find me in the halls. Come and find me at lunch. I haven't taken a lunch since October. Come and find me during B lunch. B lunch, A lunch, C lunch, whatever. I don't care. Come and find me. I want to help you guys out. So this is it. This was a great ride. I love you all. Mr. Russell signing off.